Hi all. Our next topic to study is photolithography. Okay. In this case, in this part, we will study the various steps for photolithography. First of all, what is mean by photolithography? We are going to. It is a process. It is a process by which light is transferring patterns on substrate. Mainly, this process is occurring using for semiconductor manufacturing. That is, we are photolithography means there is a photo, which means that there is a light. This light is using to transfer patterns on the substrate. That is mainly occurring in the we are using applications are major applications are in semiconductor manufacturing. So this process involves several steps, which include substrate preparation, photoresist coating, exposure, development, and etching or implantation. These are the various steps for the photolithography. In this process, there will be substrate preparation, then photoresist coating, then exposure, then development, and etching. So the key is to create a pattern on the substrate that can be used as a mask for subsequent process. That is the main thing used in the photolithography. So which is a process by using light to transfer patterns on a substrate. So this photolithography method consists of substrate preparation, photoresist coating, exposure, development, and etching. These are the major steps for photolithography. So this picture represents it is an actual image of photolithography. So it is a fabrication process which is having wide range of industrial applications, ranging from manufacturing microelectronics and a micro electromechanical component to thin film patterning for biosensors, and there are a lot of applications for photolithography. This images represent the photolithographic process. So the major steps are: first one, preparation. That is, the substrate is prepared. Substrate is cleaned and prepared for the process. Then coating. So a light sensitive material which is called photoresist, which is applied to the substrate. Then the third step, exposure. That is, substrate is exposed to light through a patterned mask that is creating a pattern on the photoresist. So first we will prepare the substrate, then we will use coating, that is by using photoresist, then we will expose the light, then development. The photoresist is developed and revealing the pattern. Then finally etching. In this case, the substrate is etched to create a desired pattern. So these are the major steps for photolithography process. So for a nanoparticle generation with the positive resist, there are two types of resist: positive resist and negative resist. Okay, in the case of a positive resist, first we will you can see this is a schematic representation of the generation. First, a metal film is deposited on the substrate. In this diagram, you can see that a metal film. It is a metal film which is deposited on the top of substrate. In the second stage, a photoresist. You can see the thin layer. It is a photoresist which is spin coated by using okay, there is an instrument for spin coating. So by using that, there is a spin coating on the sample and a soft bake process. Okay, baking process. Baking process means which will heat up to about between 60 degree to 100 degree, about half an hour. So in the first case, we will metal film is deposited on the substrate. In the second stage, a photoresist is spin coated on the top of the metal. In the third stage, the sample is then illuminated through mask with a suitable length light. So you can see that a light is incident on the photo mask. This is a substrate, it is a metal, it is a photoresist. Above that there is a photo mask. So light is passing through this area, and at the center portion there is no light is passing. Okay. So you can see that in this diagram we will get a that is the structure of the mask is imagined on the resist and cause a photochemical changes therein. So the resist is developed and hard baked about 120 to 160 180 degree. So this the structure of the mask is imagined on the resist, and then we will heat the setup between 120 degree to 180 degree. Then finally you can see that in this region there is no need of metal, so we will etching the metal. The open metal areas are etched away. Okay, then we can see that this photoresist is removed and leaving the metal nanoparticles on the substrate. The photoresist is removed. Okay, this part is removed, so we will get the metal particles on the substrate. So this is the final stage. Now in the case of a negative resist, in the previous case we studied for nanoparticle generation with a positive resist. In this case it is a diagram represent nanoparticle generation with a negative resist. In this case the photoresist is directly deposited on the substrate. Okay, photoresist is, in the previous case it was on the top of a metal. In this case we will use directly on the substrate. Then we will baking, and afterwards the resist is exposed via the mask with light and developed a hard block baked. So you can see that there is a void area is created. Now this void area is filled due to deposition of a metal film onto the sample. So these void areas are filled with some metals. You can see here also some metal is filled here, right? Then finally the residual resist, you can see that these resists are removed, chemically removed, so leaving behind the metal nanostructure. So we will get the metallic nanostructure. So there is this part and this part, we will get a metallic part, metallic nanostructure. So these are the two methods. Two method means in the first case it is a positive resist method, in the second case it is a negative resist method. So this is the method of photolithography. Okay, thank you.